So balancing a nuclear chemical equation, what we need to do is we need to make sure that the mass number A is the same on both sides of the equation when we add them all together, and the atomic number or the proton number, they must be the same sum on both sides. So what we're essentially doing here in this equation is we have like one blank on the reactant side. We're solving for A and Z, and then we'll have to deduce the identity of the element X in this gap. So let's look at the mass numbers first. So we've got 3 plus A, whatever that is going to be equal to 4 plus 0. So from that, I can tell that A must equal 1. Okay. Mystery nuclide has A of 1. That's the mass number. So then on the bottom, we have 2 plus Z, whatever that must be, is going to be equal to 2 plus 1. Um, so 2 plus 1 is going to be 3. Therefore, Z must also equal 1. Okay, so notice that it's a positron that is being emitted there because that's a +1 charge on a particle that is like an electron but not an electron. It must be a positron. Okay, so then I can actually fill in my symbol here if I can fit it in. So it's going to be 1. I'm going to put it over here and then move that thing. Mass number of 1, proton number of 1. The element identity comes from the proton number, so look it up in the periodic table. Z equals 1 is, of course, hydrogen. So then we can take this and it's going to go in here on the left-hand reactant side, okay? Okay, so I guess I can look and see if there's another one just to get us a little bit more experience because those are fairly quick and easy to answer. Scrub this out. All right, so this time we are looking at what the mystery symbol is on the product side. So again, we can try and work out what A is and try and work out what Z is. And if Z changes, then the identity of that element of the daughter nuclide is going to be different. Okay, so on the top we have 22 equals 22 plus A. So that's telling me that the mass number is not changing. So it looks like we are either going to be emitting a beta particle, aka an electron, or a positron. Let's see what's going on with the charge. So we've got 11 equals 10 plus Z. Therefore, Z must equal +1. So that's telling us it's a positron emission. Okay, so we can actually work out the mode of nuclear decay from answering these kind of questions. So 0 and +1 on the bottom is giving us a positron, which you can either write as a beta plus or an electron plus, or I think in ALEKS they actually tend to leave the plus off. Either way, as long as you've got that +1 on the bottom, not a -1, that's telling you it's a positron, not an electron. All right, let's go for the hat trick because why not? These questions are pretty quick to answer. All right, fill in the missing symbol. Is this an interesting one? I guess we'll find out. All right, so this one then, what have we got here? We look like we are doing neutron capture here because if we fill in the missing symbol, 238 plus A equals 239. So A equals 1, and then 92 plus Z equals 92, so Z equals 0. That's telling us it's neutrally charged, right? So mass of 1 and charge of 0, that is a neutron. So a neutron is going to be 1, 0, N. So that's neutron capture. So neutron capture is the reason why when nuclear reactions produce neutrons, you can get that snowball chain reaction effect because then neutron bombardment can cause subsequent nuclear reactions to occur over and over and over. All right, so hopefully that is enough for you guys to get an idea of how to approach those kind of questions.